Sekejap, Okay. All right. Now, can you see my screen?
Yes.
Boleh.
Okay, now good. Okay, so welcome student class. Okay, for today's class, we're going to talk about plane motion of rigid body. Okay, now for plane motion of rigid body, you need to understand there are two methods here. Method one is work and energy method. Method two is impulse and momentum. I'm sure everybody is familiar with this principle of work energy and principle of impulse and momentum. You have learned it when we did uh, on particles. Okay, now what we're going to focus is on rigid body. Okay, previously we did for particles. Now we're focusing on rigid body. Now, the formula, the main principle formula for work energy. Oops, sorry. The main principle formula for work energy is the same for particles and rigid body, which is T1 plus summation forces of work from 1 to 2 equals to T2. Okay. And it's also same with impulse and momentum for particles and rigid body, which is L1 plus impulse 1 to 2 equals to L2. So these two formulas that you see here is very similar with the formula that you did for particles. But now today, what we're going to do, we're going to focus on rigid body. Okay, now rigid body, as you know, there is an additional motion. What is the additional type of motion? Can anyone tell me? For rigid body, there is an additional type of motion. It starts with R. Nur Sabrina binti Muhammad. Nur Sabrina, are you here? What is, yes, what is the answer? It starts with R.
I'm not sure.
Okay, lepas tu O.
Rotation.
Yes, rotation. Kan we have gone through this many times. So
Okay.
when we talk about rigid body, instead selain daripada translation, dia juga ada rotation. Okay, a combination of both. Translation ni you dah faham dah. Rectilinear motion, kan? Dengan curvilinear, kan? Okay, rotation is the extra additional type of motion that occurs in rigid body. In particles, tak ada rotation. Understand? Okay, Sabrina? Okay, now if you look at this formula for kinetic energy, previously when you studied particles, the only formula that is in kinetic energy is only 1 over 2 mv squared. Okay, now before this, previously when you learn the topic particles, okay, particles, Ke atau Ti is only 1 over 2 mv squared. But now, because we're doing rotation, now because we're doing rigid body questions, there is an additional rotation. What is the additional formula in kinetic energy? Can you see? Mirza Alif, what is the additional formula? Can you please read this additional formula to me? Mr. Mirza Alif,
Ya,
what
yang
is this
half tu.
addition? Yes, half mana? Half apa? Half?
Half I.
Yes, and then?
Angular velocity square.
Yes, half I omega squared. Yes. So this formula is for rotation. Okay? Alright, so when you are involving topic rigid body, there is an additional formula of half I omega squared. Okay, similar dengan impulse or momentum. Previously, when you learn particles, the linear momentum is only I omega. Sorry, terbalik pula. Maafkan I. Is only mv. Now there is an additional formula. Mirza, can you read the additional formula again for impulse and momentum?
I omega.
I omega. So this is the additional formula. Okay, now, but it depends on the question. Sometimes in the question, you need to consider 1 over 2 mv squared. and 1 over 2 I omega square. Ataupun ada dalam question, you only consider 1 over 2 mv square. Tapi tak payah 1 over 2 I omega square. Ada dalam question, you tak consider 1 over 2 mv square. You hanya consider 1 over 2 I omega square. So it depends on the question. So you have to read the question carefully and have a look. If there is a velocity involved, it means the rigid body is moving due to velocity, then you can consider 1 over 2 mv square. If there is no movement of velocity involved, it means the rigid body does not move due to a velocity, it is only rotating, then you only use 1 over 2 I omega square. Tapi ada juga soalan, dia moving and rotating. Kalau dia moving and rotating, you consider both equations. So that's why you need to try a number types of questions so that you can see does it involve movement and rotation as well, or is it only rotation only, or is it only translation only? So that's why we have to have a look and check. Okay, all right. Now, so today's class, the objective that you see here is for work and energy. So for impulse or momentum, okay, this topic here, we are going to learn tomorrow's class, hari Selasa, For this topic, this is what we're going to learn today. This is today. Today kita buat hari ni, kita buat work energy. So this is the objective for work energy. Okay, so you all dah salin, so let's read together the objective for today's class. So for the objective for today's class, kita nak develop the formulation of kinetic energy of a body and define the various way of force or couple moment work. So there will be involved a force, there will be involved couple moment. Okay, you will see that. And then what we're going to do, we're going to apply the principle of work and energy, iaitu T1 plus summation of work equals to T2. Kita nak solve rigid body planar kinetics problems that involve apa? Force, velocity and displacement. Because force, velocity and displacement is involved in the formula of principle of work energy. Now, siapa yang kat sini yang tahu perbezaan work energy dengan impulse? Siapa yang boleh tahu? For work energy, kita fokus work can only happen due to displacement kan? So that's why work energy mesti ada displacement. Kita nak solve for displacement. Tapi untuk impulse and momentum, dia tak ada displacement. Dia ada apa? Siapa can tell me the answer? Mr. Zaki?
Time.
Time. Siapa jawab tu?
Saya.
Saya tu siapa?
Mirza.
Mirza. Good. Okay, hebat. Kalau ada bonus mark kat you, I bagi kat you. Sebab tiga-tiga kumpulan tadi, you seorang je boleh jawab. Okay, time. Good. It means you have been observing the previous class. Well done, Mirza. Okay, so impulse or momentum, dia ada time. Sebab impulse 1 ke 2, dia punya integration is due to time. Kan? Okay, so that is the difference. Sebab I'm going to mention this again. Sometimes in the question, they don't tell you, use work and energy method, use impulse and momentum method. You don't know. Sometimes dia tak cakap. Tiba-tiba soalan dia kata calculate the time taken for the tire to rotate, blah, 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 blah. Okay, now, dia kata calculate the time. Tapi dia tak beritahu method apa. So obviously when you hear that, you know that you need to use impulse and momentum. You cannot use work energy because dalam work energy, dia tak ada function, dia tak ada apa? Time dalam tu. Dia ada displacement. Okay. As long as you understand that, it's okay. Good. Okay. Now, kita nak understand konsep dulu. Once you understand the concept, sepatutnya kalau soalan tu berubah, bertukar, you can do it. Okay. Now, I need you to copy this. Can you please copy this? Okay, now. Okay. Oops. Hilang screen saya. Sekejap. Okay, sorry. Now, can you see my screen?
Yes.
Yes.
Okay, please copy this. Copy this first, and then let me know after you finish copying it. Okay. Okay. So, macam mana? Are you still copying? Hafira?
Belum.
Okay. Belum lagi ya. Okay. Okay. Lamanya salin.
Dan
Dah salin dah.
Dah, dah siap.
Okay. Dah siap dah? Wah, apa jawapannya? Okay.
Dah siap salin.
Saya salin. Alright. Okay. Never mind. Okay. Now. Okay. Alright. Now. Okay. Untuk formula work energy, T1 plus work equals to T2. Macam saya sebut tadi, kinetic energy dia ada satu due to translation, satu due to rotation. Okay. Now. Okay. Kalau dia due to rotation saja, formula ni tak ada. Okay. Okay. Formula ni tak ada. Dia hanya 1/2 I omega square. Tapi kalau dia ada rotation and translation, you kena campur dua-dua lah. Kalau dia translation je, dia atas macam saya cakap tadi lah. Okay. Alright. So sepatutnya saya itu je lah. Okay. So translation you all tahu dia to rectilinear atau curvilinear. Rotation dia rotating. Okay. About a fixed point. Okay. Tu you all faham. Okay. Now. Sebelah sini pula. Now work. Work can be due to many types. So bila kita baca soalan tu, kita kena decide what type of work is involved for each question. Okay. All right. So work due to variable force. Okay. Basically, the work due to variable force maksudnya ada external force that is acting on the body, that is causing the force of the body to move along a path. So for example, okay, kita buat gambar kacang lah. Let's say this is our rigid body. This is our rigid body. It is moving from here to here. Okay, our rigid body is moving from here to here, and the distance of the movement is s. Kejap. Hmm, Sekejap Okay, dia punya distance movement is s. So assume this bentuk kacang is a rigid body and the distance movement is s. So let's assume there is an external force. Let's say ada external force F lah. Okay, that's why I buat bentuk F. Let's say there is an external force F acting on this body yang bentuk kacang ni, and the force is moving the body to move from one position to another position where kita namakan dia S. Okay, so again kalau kita resolve force ni dia akan jadi F cos theta lah. Okay, that one you all semua tahu dah kan. F cos theta. So if it's work due to a variable force, then dia punya work UF equals to integration of F dr or equals to the integration of F cos theta ds. Okay, so this is it lah. Okay, next is due to weight. Okay, kita juga ada work of force due to weight. Okay, so the weight of this body, a weight of a body, let's say kita have a weight again bentuk kacang. This weight of the body is causing this kacang to move to another position lah due to weight. Okay, so this distance here is what we call delta y lah. Okay, so sometimes work can also due to the weight. So basically the due to weight it means dia punya mass ni is undergoing a displacement that kita labelkan dia as delta y due to weight. Okay, that's why formula dia kat sini. Yang ni formula dia, that's why formula dia adalah negative W delta Y. Okay, now kita juga ada force that occurs due to spring. Okay, now let's say we have a spring. Okay, now this spring is label distance dia label S. S ni kita panggil dia unstretched. Let's say this is the original, right? Unstretched. Now, spring ni kita boleh make the spring stretch even more, betul tak? So, kita juga boleh make the spring to reduce its length kan. Dia boleh stretch dan unstretch lah. Stretch ke belakang S1. Ke depan lagi S2. Ni due to spring ya. And then we also have work that is due to couple moment ya. So due to couple moment, let's assume there is another rigid body macam bentuk kacang kat sini, and there is a couple moment M that is causing the rigid body to move, okay, and the couple moment is moving with angle theta. Okay, alright. Okay, that is another example. And kita also ada force that do not do work. Bila you understand it does not do work, it means it does not move. Let's say kita punya example kali ni a pulley a circular pulley. Okay, let's say this pulley. Okay, this pulley does not do work. So maksudnya bila dia tak do work, dia doesn't displace or move in a different direction. Dia pin kat situ saja. So dia boleh pin kat situ, dia ada normal force, dia ada friction force dan dia ada weight. Tapi bezanya dia rotate saja. Okay. Alright, so ni R. Okay. So this is just the understanding lah. So basically there are 4 main types lah. Okay. Alright. So nanti bila kita dapat soalan tu kita kena decide untuk kinetic energy kita nak consider 1/2 mv squared saja ke 1/2 I omega squared ke ataupun both together. And then bila kita nak buat dia punya work, ia boleh jadi combination spring dengan weight. Dia boleh jadi combination spring dengan moment. It depends. Bergantung kepada soalan tu. So let's try one tutorial question together and see whether we can understand to solve the question. Boleh? Can we try and do one tutorial question together now?
Boleh.
Boleh, okay. Alright. Okay. Now please copy this question and let me know after you have finished copying. Dah?
Dah.
Okay, good. Okay, now let's read this question together. Okay, alright now. The 30 kilogram disc is pinned, supported at the center. Determine the angle. So now dia nak angle. Determine the angle which it must rotate to attain an angular velocity. Okay, angular velocity tu apa? Simbolnya apa?
Omega.
Okay, so omega kita adalah 2 radian per second. Starting from rest. Okay, what do you understand bila dia kata starting from rest? Apa clue yang kita boleh tahu? Bila starting from rest saja kita punya?
Omega naught 0.
Okay. So it means our T1 will be equal to 0 because they're starting from
0.
rest. Yes. So tu keyword kita ada. It is acted upon a constant couple moment. So ada couple moment which is 5 Newton meter. And the spring is originally unstretched and its cord wraps around the rim of the disc. So spring ni dia wrap around this disc lah. Okay, alright. Now, so first kita akan write down our main formula for principle of work energy. T1 plus work equals to T2. We know T1 is already 0, so we need to find T2. Now, for T2, okay, as I mentioned, now, what formula you're going to use for T2? Now, we know kinetic energy, we ada satu, 1 over 2 mv squared. Lagi satu ialah 1 over 2, apa? I omega squared. Now, for the kinetic energy here, now, is the pulley, the mass has a velocity and is it moving? Is the pulley moving? Does it have a velocity? Is it moving? Tak tahu. Okay, it's not it's not moving. Dia tak bergerak. Dia dekat situ saja. But the only thing that is happening, it is rotating. So bila dia rotating saja, the kinetic energy that you need to consider is 1 over 2 I omega squared. Okay? 1 over 2 I omega squared. Okay, now. Okay tak guys? Boleh I continue? Do you understand?
Okay.
Okay, because the wheel is not moving. Okay, it does not move the kinetic. So there is no kinetic energy due to velocity. However, it is only rotating at the same position. So when it's rotating at the same position, dia punya kinetic energy is only 1 over 2 I omega squared. Now, I ni adalah moment of inertia. Okay, I kita ada banyak formula ya. Selalunya kadang-kadang dalam exam kadang-kadang dia bagi, kadang-kadang dia tak bagi. So kalau dia tak bagi, you need to remember dia boleh jadi IDIS, IROD. Tapi this is the most common lah. Nah, kalau IDIS, formula untuk dia adalah 1 over 2 mr squared. Kalau IROD, formula dia adalah 1 over 12 ml squared. Now, so basically you kena tengok the question sebab some question ada juga rod dalam tu, rigid body. Kalau rod you kena pakai 1 over 12 ml squared lah. Tapi kalau dia disc dia 1 over 2 mr squared. Tapi ada lagi satu formula disc yang kita guna sebelum ni which is mk squared. Now, k ni adalah radius of gyration. Okay, now dalam soalan ni kalau dia bagi tahu K equals to radius of gyration, bila you nak calculate I untuk this, you kena guna formula MK squared. Tapi dalam soalan ni, ada tak dia bagi K radius of gyration? Yes or no? Dia ada bagi tak K radius of gyration? Apa dia?
Ada.
Mana?
10.
Ada.
Okay,
Ada.
ini bukan. Ini K ni yang you nampak ni ialah stiffness. Okay. K stiffness unit dia Newton per meter. Tapi K radius of gyration unit dia meter. Simbol dia sama tapi lain unit. Okay, so dalam soalan ni dia tak bagi radius of gyration. Dia tak sebut pun radius of gyration berapa value. Dia tak sebut pun. So automatically bila dia tak sebut, you kena calculate I pakai formula first ni which is 1 over 2 mr squared. So you akan calculate 1 over 2 mr squared. You kena pakai formula ni lah. Okay, saya ulang balik pula. You kena pakai that formula lah. Okay, this formula. You kena pakai formula ni lah. Okay, untuk I this. Okay. Okay. So let's calculate formula T. Okay, now. So T2 equals to 1 over 2 I omega squared. So 1 over 2 dalam kurungan 1 over 2 mr squared tutup kurungan omega squared. So 1 over 2 kali 1 over 2. Okay, what is the mass of the disk? What is the mass of the disk?
30.
Okay, 30. What is the radius of the disk?
0.2.
Okay. Okay, tutup kurungan. What is omega?
2.
2 kuasa 2. So please calculate for me what is kinetic energy? 2. What is the answer that you get? Cepat sikit. What is the answer? Weh, lamanya calculate.
1.2.
1.2.
What is the unit? Kita kan dah buat unit dia apa?
Joule.
Joule.
Joule. Okay, now. Alright, now next kita nak work on work. Okay, now. So, can you tell me what type of work is in this rigid body question?
Spring.
Yes, good. Spring. Lagi satu?
Wait.
Couple moment.
Couple moment. Tak ada weight. Dia not changing position. So, dia bukan couple moment. Dia bukan weight ya. Dia hanya apa? Dia hanya moment and spring. Okay, so for moment, m theta for spring is just negative 1 over 2 ks squared. Now, the moment dia dah bagi dah value dia. What is the moment? What is the
5.
moment? 5. Okay, 5 theta. And the spring, what is the K, the stiffness of the spring?
10.
10. Now, okay, what is S? Okay, now, if you notice, okay, the spring, mana gambar spring tadi? Oops. Oops. Okay, ni gambar spring tadi. Okay, let me redraw balik kat sini supaya boleh nampak. Okay, the spring is attached. Kan, dia fix kat bawah ni, dia tak bergerak tapi dia boleh stretch kan. So spring ni dia bergulung-gulung dekat atas ni. Dia bergulung-gulung kat atas ni, dia berpusing. So ini adalah S, ni adalah R, ni adalah theta dia. So kalau kita nak dapatkan S equals to R theta. Okay, right. Formula tu adalah formula lilitan ya. So kita punya S ni adalah R theta kuasa 2. So dua-dua unit dalam theta. Baru you boleh selesaikan. So 5 theta minus 1 over 2 kali 10. Nah, kita punya R radius adalah 0.2 theta kuasa 2. Okay. Now, sekarang ni kita boleh masukkan dalam formula untuk dapatkan theta. Okay. Nah, kita masukkan kita punya main formula of principle of work energy T1 plus work equals to T2. So T1 kita adalah kosong, T2 kita adalah 5 theta 1/2 tan 0.2 theta kuasa 2 equals to T2 tadi 1.2. Okay, now so tolong cari saya theta. You akan dapat dua value theta. Bagi saya theta yang paling kecil. Tolong calculate pakai calculator. Dapatkan value theta. Dah? Oh, lamanya. Kita kena cepat.
0.24.
0.24 berapa? 0.24 berapa?
Tepat 0.24.
0.24. Lepas tu?
Dia 0.237.
Ya ke? Ada tak yang dapat 0.242?
2423.
2423. Okey, ini jawapan dalam radian Kita kena tukar ke angle Kalau nak tukar ke angle macam mana? Multiply 180 divided by pi So you multiply dengan 180 divided by pi dapat berapa? Dapat apa?
13.
13 point?
88.
Okay, 88. Okay, so around 13.9 Okay, angle. Betul, itu jawapannya. Okay, so now let's recap what we have done. Okay, so basically number one, kita study about work and energy, principle of work energy for rigid body. Semua understand the formula is T1 plus work equals to T2 and student kena decide what is happening in the question. So for our question ni, what we notice is the disc is rotating only and nothing is moving. Right. So moving with the velocity. So basically we only consider formula kinetic energy equals to 1/2 I omega squared. And then secondly for the work, there's only work due to moment, which is the rotating, the moment is rotating with the angle. And then also the spring. Okay, the spring is going to be work due to spring, where the spring is gonna go through this lah, dia masuk dalam this ni lah, dia akan stretch masuk dalam this ni lah. So there's only two work that occur in this question. Satu due to the couple moment and the other one is due to the spring. So every question is different, so student must understand. So basically for this type of question, kadang-kadang dia tanya force, what is the velocity, displacement, dia boleh tanya angle, whatever parameters is involved lah. Okay, and then for tomorrow's class, nanti kita akan discuss on impulse and momentum, kita akan look into time. Okay, so that is the end of today's class. So I will stop recording now. Okay, sekejap.